Okay, by popular demand, Yushin Jeffrey, this is number 23 and number 24, looking at cosecant and sine. So first of all, we know that cosecant is the reciprocal of sine, 1 over sine. So the only place they're going to intersect is when sine is 1. Because when sine is any other value, we have 1 over that value. They're not going to be equal to each other. So the only place they intersect is at 1 and at negative 1. So first, let's just get the graph of sine on here. I'm going to choose to go from negative 2 pi to 2 pi. Negative 2 pi to 2 pi. All right, so then here's pi. Here's negative pi. Here's 3 pi over 2. Here's pi over 2. Here's negative pi over 2. Here's negative 3 pi over 2. All right, so sine starts at 0. It goes up to 1, back down to 0, down to negative 1, back up to 0. Okay, same cycle over here. Okay. All right, so then thinking about cosecant now. So we know that they're going to intersect at x equals pi over 2 and y equals 1, x equals 3 pi over 2, y equals negative 1. Because again, at these points, we have 1 over 1, which is just 1. So then we're at negative pi over 2, and then we're at negative 3 pi over 2. All right. So these other values of sine, they're not going to be equal to, like if we pick another value on our sine graph, like right here, well, cosecant's not going to intersect there because we're doing 1 divided by whatever this is, which is going to be a little bit bigger. So let's think about the shape of cosecant. Cosecant is 1 over sine, so as sine becomes smaller and smaller and smaller and smaller and smaller, we're doing 1 divided by a number that is getting smaller and smaller and smaller and smaller. So we've worked with limits a lot, and we've worked with this enough to know that when we take a number divided by a really small number, it's going to become really big. Really big. And then we know cosecant's going to be undefined whenever sine is 0, because that's 1 divided by 0. So wherever sine crosses through the x-axis, we're going to have a vertical asymptote. Should be crossing through a negative pi there. All right. So then what's happening in the negative side is, again, sine is becoming closer and closer and closer and closer and closer and closer to 0. As that's happening, we're doing 1 divided by a number that's getting closer and closer and closer and closer and closer and closer to 0, right? We're doing like 1 divided by negative 0.00000001. As we get closer and closer to 0, that number is going to become a bigger and bigger negative number. So what's happening is this thing's shooting down, shooting down. All right, this one's shooting down, shooting down. You're good. You're good. I'll be done in a sec. Shooting up, shooting up. All right, so what we have is we have our sine graph, and then on top of each of the humps, cosecant's shooting out of that, either up or down, depending on if sine is positive or negative. And it makes sense because cosecant is equal to 1 over sine, right? 1 over sine. So then that's why the shape of cosecant makes sense. We just have to think about what's happening to sine and how that's affecting 1 over sine. All right, let me pause it for a second because I can't remember if it asked anything else. Okay, yeah, that's all it asked. So I hope that this is clear enough. You just have to think about how cosecant and sine are related. You should have a solid understanding of what the graph of sine looks like. And then knowing that cosecant is the reciprocal of sine, that should help you figure out how the graph of cosecant should look. And that's all I got for you.